Hello friends, welcome to the Mathematics Enthusiast channel, and today I've come across a new problem from the chapter limits, and let's have a look at it. We are given limit x tends to pi by 2 sin x minus sin x raised to power sin x upon 1 minus sin x plus ln sin x, and we have to find this limit. If you want to give it a try, pause the video, and now I am giving the solution. So what we can do first, we see that all the terms contain the expression of sin x. So what we can do, we can first substitute sin x is equal to t. So when sin x, when x tends to pi by 2, then we can say that sin x tends to 1, okay, because sin pi by 2 is 1. So when x tends to pi by 2, we can say that sin x tends to 1, and hence we can say that t tends to 1. So now we have a new expression, which is limit t tends to 1, t minus t raised to power t upon 1 minus t plus ln t. Alright, now let's analyze this limit. Okay, first we will check whether it is an indeterminate form or not, because if it will not be an indeterminate form like 0 by 0, infinity by infinity, or many more, then we can finally put this value and we can find the limit easily. So let's check over here. When we put t is equal to 1 over here, we get when t tends to 1, this term tends to 1, and this 1, I will write it here, this tends to 1, minus this is 1 tending upon 1 tending. I am showing this arrow to show that it is tending towards 1. So 1 minus 1 tending over 1 tending, which is ultimately equal to, we can say 1, upon 1 minus this is also tending to 1, and this is tending to 0 because ln 1 is 0. Okay, so we see that it is 0 by 0 form. Okay, we see that is 0 by 0 form. So now what we can do, we can apply the L'Hopital rule. Now L'Hopital rule states that I think you I will show you, I will explain a small part of it, the L'Hopital rule. What the L'Hopital rule states? Now it states that if there is a limit, okay, I will state the L'Hopital rule over here. L'Hopital rule states that if there is a function, if there is a limit x tends to a fx by gx, and we come to know that it is of the form 0 by 0 or infinity by infinity. So what we can do, we can differentiate both numerator and denominator separately, and then we can treat it as a separate limit. So the same thing we'll do here. So this we can write it as limit x tends to a f dash x upon g dash x. Alright, so now we come back to our new given problem. It is limit t tends to 1. We differentiate it. Now for differentiation of t raised to power t, I am doing it here on the side. Okay, t raised to power t, let's say it is y. Take log both sides. T ln t is equal to ln y. Okay, differentiate it with respect to t. So we are left with t. We'll apply the product rule. T into differentiation of this, which is 1 by t, plus ln t, and differentiation of this is 1. This is 1 by y dy. Okay, so dy by dt, this is the case. This cancels out, and we are left with, okay, we are left with dy by dt is equal to y times 1 plus ln t, which is t raised to power t 1 plus ln t. Alright, so now we come back to the problem. It is yeah, now I think it is clear. So what we do, we differentiate the numerator first. Differentiation of t is 1. minus this we have found over here. Okay, this we found over here, this one, so we'll put it over here, t raised to power t 1 plus ln t upon, now differentiation of 1 is 0, differentiation of t is 1, and differentiation of ln t is 1 by t. So now we simplify it, 1 minus t raised to power t minus t raised to power t ln t upon minus 1 plus 1 by t, and yeah, sorry, I forgot to write the limit, just t tends to 1. Now we observe once more. Now we treat it as a separate limit. Now we'll analyze it once more. We see that when t tends to 1, this is already 1. This tends to 1 because 1 to the power 1 is 1. So 1 minus 1, 0. Then t raised to power t tends to 1, but ln t tends to 0. So the whole numerator tends to 0. And here, when t tends to 1, this whole part tends to 1, and 1 minus 1 tends to 0. So it's again a 0 by 0 form. So now we will have to again apply the L'Hopital rule, and L'Hopital rule states that we'll differentiate the numerator and denominator separately. Now differentiation of this we have found here, which is minus t raised to power t 1 plus ln t minus, now the differentiation of this, it will we will again apply the product rule. So now I'm writing it slowly. Differentiation of this, keeping this as it is, ln t, differentiation of this is t raised to power t 1 plus ln t. Okay, I'm putting in brackets, minus differentiation of this part into this, so t raised to power t upon t, done, upon minus 1, differentiation is 0, 1 by t, differentiation of minus 1 by t square. Okay, now we have to simplify it a little bit, so we are left with limit t tends to 1 minus t raised to power t 1 plus ln t, and if even if you don't open the bracket, then also it's okay. It is t raised to power t ln t 1 plus ln t minus t raised to power t minus 1, because this comes in numerator, so its power is minus 1, so we add them, t minus 1 upon 1 minus 1 by t square. Now we analyze it once more. When t tends to 1, t raised to power t tends to 1, and 1 plus ln t also tends to 1, so it is minus 1. Then here minus, this whole fraction tends to 0 because this ln t tends to 0, so whole fraction tends to 0. Okay, so it will be 0 minus this whole part, okay, sorry, this will be plus, yeah, in the product rule we have plus in the between, so this will be plus, so this tends to 1 because 1 raised to power 0 is 1. Okay, when t tends to 1, then t minus 1 tends to 0, so 1 raised to power 0 tends to 1 upon it is minus 1 by when t tends to 1 it is 1. So now we simplify it, we are left with minus 1 upon this, we are left with 2. So therefore the limit which we have to find here, this one, so this limit is equal to 2. Okay, so we have finally found the limit. Hope you liked this video. If you like this video, please share and subscribe the channel. Thank you so much.